Welcome back. This is the second lesson recording for IM2, February 1st, 2021. So we've just figured out all the key attributes. That's the y-intercept and the vertex and the line of symmetry and whether it's opening up or down of this equation, quadratic equation in vertex form. And something you should know is the vertex form is a graphing form. What do we mean by that? It's super easy to go from vertex form to sketch a graph. So to sketch this graph, the information we found was this. Okay, so it opens up, the vertex is -2, 7, y-intercept is 0, 3, and line of symmetry is x is equal to -2. So let's see if we can graph this. Okay, so and this is just a quick sketch. It does not have to be even to scale, though you want to be somewhat generally to scale so that you can see your shape pretty well. So the vertex is -2, 7. So let's just say this is my -2. So I know that it's opening down and I have the vertex of -2, 7. So I put my vertex here. Y-intercept is 0, 3, so that's going to be right here. Okay, I know the line of symmetry always goes through the x-coordinate of, oops. So imagine it's a straight line. I do not have my pen with me, so that's my problem. Okay, and then from here, okay, with 2 points, you can't really draw your graph. That's not going to be you can't draw any graph. Okay, however, knowing that this is a vertex and we know the line of symmetry, then we can use the fact that quadratic equation is always going to be symmetrical and put another point right here. Okay, and what does that point represent? That's going to be -4 and 3, -4 and 3, because it's always going to be symmetrical. Okay, now I have 3 points, and that's pretty good that we can draw a decent graph. Like so, and like so. Okay, so these are going to be my 2 parabolas. And please extend your graph beyond the x-intercept. Some of you are stopping right at the x-intercepts where the parabola extends forever. Okay, so this is the graphing of the equation that we just found. Okay, so now you're going to just do a quick card sort from vertex form, and the link is in Canvas. Again, this is the Desmos activity. It's just one card. You're just doing a card sort. You have 7 different graphs and 7 different equations. You need to match them up. Okay, so all right, let's find some easy ones. Okay, so when I look at this, oops. Okay, is this x squared? It's almost like x squared, but it's not. Let's find all our equations first. There should be 7 of them. I am just going to bring them all to the top so that we know what you're dealing with. Okay, none of these are matched because they're not supposed to be. Okay, so what's the most basic of the graphs? Y is equal to x squared. That's our parent function. That's going to be opening up. What is the vertex? It's going to be like 1 x squared, x plus h is going to be 0. And k is also going to be 0. So that means the vertex is at 0, 0, and it's opening up. And that will be this one. So I will bring this over here and match that up. Okay, and you just keep matching all the rest, please. So please pause the video and try to match them yourself. This is the other most basic parabola, the parent function, but this time it is opening downwards because a value is -1 here. What about this? We have the vertex of -3, 0. Okay, then what should the equation look like in vertex form? -3 means it's going to be, h value is going to be -3. So it's going to be x minus -3, so it's going to be x plus 3, and it is opening down. And the y-coordinate of the vertex is also 0, so that's plus 0, so this matches with this equation. Okay, so with the matched ones, I am going to put them over here to declutter. And I know this was not properly matched. Okay, so then we are left with few other ones. Look at this one. Okay, we have vertex of 1, 0. Positive 1. That means we want what's inside the parentheses to be -1 here, and the y-coordinate to be 0. Okay, so but this is not it. Unless this one is. Okay. What's the vertex in this case? It's 0, -2. That means there is no term. It's going to be x minus 0 all squared, which is same as x squared. And this e looks like -3. Yeah, so it's -3 here. So that matches up with those. And then what's the vertex here? That's positive 1, 3. 1, 3 would match up with this. Remember, it's the negative version of the h. Okay, and then this one must match up with that, and which gives me feedback saying that you got it. Okay, see if you can recognize this person. Who is he? What about him? And him? It's actually the same guy, but he just looks different. In fact, he even looks like that. Okay, so vertex form is just the standard form, vertex factored form, and vertex form. They are actually the same thing, same equations, or we're talking about each equation can be represented in 3 different ways. Factored form, standard form, and vertex form. They all have very different format. Okay, some are better for other things. Factored form is great because it's very easily, we can very easily find out what the x-intercepts are. Vertex form, as the name indicates, we can easily identify the vertex. Standard form is the most standard form that is going to be always the standard form of a quadratic equation. And there are equivalent ways to represent the same quadratic equation, and we can convert from one form to the other. So to go from factored form to vertex form, or vertex form to factored form, that's actually not that interesting. However, going from standard form to vertex form is a little bit tricky, so we're going to leave that for IM3 next year. It is one of the standards that we did cut out this year due to distance learning. So those of you who are planning to go on to IM3 STEM, it would actually be a very good idea for you to search online as to how to convert standard form of quadratic equation to vertex form. Now we know how to convert standard form to factored form. That's by factoring. And we know how to go from factored form to standard form. And vertex form can be converted back to standard form. So let's try to do that now. Okay, so how do we convert the vertex form written in y is equal to 3 x minus 2 all squared plus 1 to standard form? Well, what I need to do is I just need to multiply it out. Okay, so but you need to use the order of operation. Exponents are always before multiplication, so you do the exponents first. So it's going to be x minus 2 times x minus 2, and that becomes x squared minus 4x plus 4 using FOIL. And then to that you need to multiply by 3 and distribute it, and you get 3x squared minus 12x plus 12 plus 1, which is the very last term. And then finally that becomes y is equal to 3x squared minus 12x plus 13. And so that is the vertex form, which just we converted to standard form. What about standard form to factored form? Well, you can use any factoring method to convert y is equal to 2x squared plus 8x plus 6. First thing you always look for is GCF. And so then you factor out the 2 and you're left with x squared plus 4x plus 3. This is the easy type, right? Easy type where you just start by putting in your 2 parentheses with the x. This 2 comes from the 2 that we factored out, so it just remains. But I'm just factoring what's in the parentheses. The only way I can get x squared is if I split it as x times x. Now I am looking for 2 numbers to fill here, and those 2 numbers has to multiply to 3, but then add to 4. So that's going to be plus 3 plus 1. So I have just factored them. So that is my standard form, and going to factored form. What about converting from factored form to standard form? You just basically multiply the binomials back. So you have negative 2 multiplied x minus 2, x plus 3. It's easier to multiply the 2 complicated parts first. So that becomes, using FOIL, x times x is x squared. Outside, x times 3x, 3 is 3x, minus 2x, and then minus 6. And then combine their like terms and you are left with x squared plus x minus 6. Remember, when you have a parenthesis, you always try to simplify inside the parenthesis whenever possible. Okay, don't go distributing this at this point, because then you are having to do the combining like term anyway, but with a bigger number. So make it easier for yourself, and then finally distribute negative 2 to each of the terms inside the parenthesis, and you're left with negative 2x squared minus 2x plus 12. So that is the factored form going to our standard form. Finally, what we did was table of content in your notebook. You are going to enter vertex form and then converting between different forms. And you are going to submit the class notes from today in classwork February 1st. Thank you for listening.